Our next speaker is Dr. Concepción Carreón Diazconti, and she's a researcher at the Institute for Engineering at UABC in Mexicali.
I'm so pleased to be here. Thank you for inviting me to talk about some research in the Mexicali Valley or in Mexico. First, let me tell you that I'm not an expert on human health. I work in the environment, but I was invited to talk about this in relation with human health, and I tried to do something about that, but my presentation focused a lot on the environment, but you will see the link, okay, at the end. This is what I'm going to try to do today. I'm going to try to answer these 7 questions. I'm going to talk about pharmaceuticals and hormones in the environment in the Mexicali Valley, in the Mexicali city and the surrounding valley. And as I don't know how much you know about these topics, I'm going to answer first why the pharmaceuticals, which I'm going to call from now on PHAR, are considered compounds of emerging concern. I'm going to tell you how do they reach the environment, what is the role of water reuse, what about environmental and human health, is Mexicali susceptible to this type of contamination, and if Mexicali is experiencing this kind of contamination, and if reclaimed water have the potential of affecting human health in Baja California. So first, why are PHARs considered compounds of emerging concern? I'm going to try to be very brief because it is, well, this is not a classroom, but I need to tell you some information about this. First, pharmaceuticals are very complex organic molecules, and this is an example. Ibuprofen is something that you are very familiar with. Remember, pharmaceuticals are developed to cure and prevent illnesses, so they are designed with the purpose of causing biological effects. And some of them damage the hormonal system. In some of them damage the genetic information of some non-target organisms. I took this example from the internet. It's kind of dramatic, but I wanted you to show what some people think that these compounds may cause in the environment. So organic compounds have some other issues related with the environment or with their characteristics. They have the potential to bioaccumulate and biomagnificate. What do I mean with this? I took this cartoon also from the internet where you can see at the beginning, but down here you can see that water contains some amount of some compound, one pharmaceutical or other kind of compounds. And in a very, very tiny amount, these has 3 decimal places in ppm, parts per million. So in the water there is some zooplankton, and each one of these guys assimilate in some way the compound, in this case is ibuprofen, from the water. And you see the amount in their bodies is a little bit higher than it used to be in the water. And then comes a larger fish that feeds on zooplankton, and the concentration in the body of this fish increases. And then comes a larger fish, and the concentration increases. And then comes another animal who comes from other environments, and the concentration increases in its body. So that's what I mean by biomagnification. The concentration in each one of the organisms is increasing. So there is another problem that is really important. These compounds are not included in any environmental regulation. That's why they are called compounds of emerging concern. And the last one that doesn't look really nice here is that these compounds are always continuously reaching the environment. And I'm going to tell you how they reach the environment. This cartoon is showing how this is the medicine, and then it is produced by a manufacturing process, and it is used in livestock treatment, in animals treatment, in aquaculture, in health, and sometimes the materials related with these pharmaceuticals is not well disposed. So at the end, we have a lot of this material coming into the soil. Let's see if I can do it here. Yeah, here. Nope, no. Okay, now those compounds are in the soil. And from there, they go to the receiving surface water or to the groundwaters. That's how they reach the environment. After consumption, many of these compounds are not metabolized by your organism, and they reach the environment in the pure state. But sometimes they metabolize, and those metabolites are even worse. They can be more dangerous for the environment than we think, than the original one. And, well, most of this water can go into treatment. I see that there were problems with my presentation. There are some overlapping letters there, but it's okay. You have seen about this in other presentations, the treatment. The raw wastewater in Mexico, sometimes, depending on the location or the situation of the villages, can go directly into the environment, go to receiving water bodies, and some other time is directed into treatment plants. And the first treatment in Mexico is just to remove whatever separates from the water, whatever goes down because it's heavier or goes up because it's lighter. The second treatment, most of the time, is related with removal of other soluble organic matter. But the third treatment is, well, it doesn't happen in regular treatment plants. Then from the second treatment or secondary treatment, this water can go to any of the three ways that you can see in that cartoon. 1, to the environment, 2, to reuse, and 3, to advanced treatment. There are a couple of advanced treatments in Mexicali. This power plant that Leopoldo mentioned is one that uses tertiary treatment for some part of their production plant. But mostly in Mexicali, water is 100% reused. Wastewater, treated wastewater is 100% reused. It is mainly reused in recreational activities, in agriculture, irrigation areas, and municipal landscaping. Aquifer recharge is not happening, at least direct aquifer recharge. But as water is moved or liberated into the environment, it interacts. The surface water and the groundwater interact a lot in the Mexicali Valley because the water level is so shallow, for one, and second, because the irrigation system there. And I wanted to show you with this cartoon that advanced treatment is sometimes risky for these kind of compounds. I'm showing you the example of carbamazepine, which if goes into photolysis becomes a more dangerous compound. If it goes to hydrolysis, breaks into a more dangerous compound. If it goes through ozonation, goes into several more dangerous compounds. And chlorination is the same. There are many risks in treatments with these kind of compounds. So research topics in advanced treatment are one of the most interesting research in this moment, because they are trying to make the treatments cost low, to lower the cost of treatment, to obtain a treatment that is safe. There are safer treatments like RO, but very expensive ones. And toxicity could be a very serious problem because you believe that treatment is going to help you, but you can see that it's not helping. It could be even worse for some molecules. So, what about environmental and human health? This is just an example. Tilapia, who likes tilapia? Many of us eat tilapia. If tilapia is exposed to ibuprofen, it alters DNA and it can cause illnesses similar to cancer. And we eat tilapia. This is a very interesting guy. It's a crustacean. It's the main food for some waterfowl. And if they are exposed to anti-inflammatory drugs and painkillers, they experience neurodegenerative diseases. And waterfowl eats them, and sometimes we eat waterfowl. And drinking water, you may think that drinking water is safe. At least 3 of the references there show that they have found 118 compounds in drinking water, pharmaceutical compounds in drinking water. So you may say that this could be very dangerous. However, remember, concentrations are tiny ones, nanograms or picograms. However, you can find them there. Okay. So there is no legal framework. There are some efforts around the world. The United States, the EPA recently decided to put some pharmaceuticals in the top list with the intention of adding them into their dangerous chemicals. The same happens with Europe, with Vietnam, but there is no real framework for these kind of compounds. So, is Mexicali at risk? Is susceptible to this kind of contamination? Well, as you may know, there are a little bit more than 1 million people around that area. Agriculture and industry is very thriving, and we have almost no rain and a lot of evaporation. Our water resources are limited, and we decided the city is treating and reusing all of the water. You can see here this is the way we use water, mostly in environmental compensation, agriculture, and municipal landscaping. This is a signal stating that they are using reclaimed water to water that garden, some fields. This is the Hardy River, which receives 30% of the water treated in the Arenitas. This is the Arenitas treatment system. And we decided to analyze for all of those compounds. We collected samples and treatment plants in the 3 stream courses and some other sites in surface water. And we already knew that some antibiotics and methamphetamines were entering into our valley through the Colorado River from the United States. So those are 12 compounds. What we found, these are the sites we decided to collect the samples. The squares are water treatment plants, and the rest are surface water. You can see at the very top, up there is where water comes from the Colorado River, comes into our country, and here is where water returns to the United States and goes to Salton Sea. This is what we found. This is carbamazepine concentrations up to 115. The circles, the highest are the highest concentrations, the smaller ones are the smaller concentrations we found. You can see that our environment contains carbamazepine. You can see sulfamethoxazole and ibuprofen. So we found that there is distribution of these compounds in our environment. And we already know that this environment is linked to human health. So does reclaimed water have the potential to affect human health in Baja California? We found 5 of those 12 compounds in our aquatic environment. The local wastewater treatment plants were able to reduce the painkillers and some other non-steroidal pharmaceuticals, but they were not able to remove some of those pharmaceuticals, 5 of them. We found up to 1,700 nanograms per liter of ibuprofen around the environment, and 800 nanograms of sulfamethoxazole in that area during the spring of 2015 when we did this. Once in the environment, the good news is that once in the environment, they seem to reduce their concentrations. You can see here, from high to none. And that's good news, because they kind of, we don't know yet what happened with them. They might be still there, but sorbed to sediments, or maybe, I don't know, they are not bioavailable, at least, it seems like. So we are working on this. This is just our first step in our research. We know that the most important advice or what we learn from this experience is that we need to improve our wastewater treatment processes with cost-effective and efficient technologies. We need to develop and implement adaptive wastewater management strategies capable of protecting the environment and, at the end, the human health, and make sure that all wastewater goes through the proper treatment before it is released into the environment. It is important that whoever is in the government should include in the short-term or medium-term agenda, environmental agenda, should include implementing continuous environmental monitoring programs, create guidelines to assess the environmental, and this is for both countries, create guidelines to assess the environmental risk, and prepare a list of priority substances. Because even if this is mainly focused on the environment, I already showed you how the environment and the human health are related.